equations with multiplication and division. Inverse operations. It says, what is an inverse? If you remember, an inverse is an opposite or something that an operation that undoes another operation. If you remember yesterday, we talked about what was the inverse of addition and subtraction. We learned that the opposite of addition or inverse of addition was subtraction, and the inverse of subtraction was addition. So addition and subtraction are inverses of each other. Then it says the inverse of multiplication is division, and the inverse of division is multiplication. Or the opposite of multiplication is division, the opposite of division is multiplication. So just like yesterday, if we're trying to solve a one-step equation today with multiplication and division, then we're going to be using inverse operations. Our goal is, again, when we're asked to solve an equation, our goal is to isolate the variable. Remember, isolate means to get the variable alone on one side of your equation or one side of the equal sign. Let's try some. When x is written over 5 like this, it's read as x divided by 5 equals 2. So when you ask yourself, what am I doing to the variable x? I am dividing the variable x by 5. The opposite or inverse of dividing the variable by 5 would be multiplying by 5. Parentheses show multiplication, so this would mean times 5. And remember, whatever you do to one side of an equation, you have to do to the other side to keep it balanced. Our 5s are going to cancel each other out, so I'm just left with x on the left side. And then on the right side, I have to do 2 times 5, which is 10. If you are going to check this solution, you plug in 10 for x, and you would have 10 divided by 5 equals 2. 10 does make this equation true because 10 divided by 5 is 2. The next example is 22 equals negative 11k. Always ask yourself, what am I doing to the variable? In this case, my variable is k. When negative 11 is written next to k with no operation signs between the two, it is multiplication. So this would be read as 22 equals negative 11 times k. The opposite of multiplying by a negative 11 is dividing by a negative 11. Whatever you do to one side, you have to do to the other side. Notice when I am multiplying and dividing and using inverse operations, I keep the sign of the number. So in my original equation, I was multiplying negative 11 times k, so I have to divide by negative 11 on both sides. When you divide by negative 11 on both sides, a positive 22 divided by a negative 11 is a negative 2 equals k because my 11s cancel out on the right side. The next example says negative 2 equals m divided by 16. Remember, what is happening to the variable is dividing by 16. The opposite of dividing by 16 would be multiplying by 16. Whatever I do to one side, I have to do to the other side of my equation. When I do 16 times a negative 2, I get a negative 32 equals m. And the next example says negative 40 equals negative 5p. If you look at the variable p, you can tell that it is being multiplied by negative 5 because it is written right next to a negative 5. The opposite of multiplying by a negative 5 is dividing by a negative 5. Remember, you keep the sign, so if I'm multiplying by a negative, I have to divide both sides by a negative. When I divide both sides by a negative, my 5's cancel out, and a negative 40 divided by a negative 5 is a positive 8 equals p. The next example says, how many boxes of envelopes can you buy with $12 if one box costs $3? I want you to write an equation and solve it to find the number of boxes you can buy. We know that the total amount that I can spend is $12 because I only have $12. You know that each box costs $3, and my unknown, or what I'm going to assign my variable to, would be the number of boxes that I can buy. So I'm going to multiply 3 times the number of boxes I could buy, which is X, equals $12. $3 is the cost of each box. 10 is the number of boxes, and then, X is the number of boxes equals 12 is the total amount I can spend. Here I am multiplying 3 times X. The opposite of multiplying is dividing, so I'm going to divide both sides by 3, and when I do, I find that X equals 4, or I could buy 4 boxes of envelopes. The next example says, at a restaurant, Mike and his 3 friends decided to divide the bill evenly. If each person paid $13, then what was the total bill? If you can think of you and 3 of your friends sitting around at a restaurant, and the bill comes, and you all decided that you were going to split it and all pay the same amount of money, what you've done to that bill is you've taken the total cost and then you've divided it by how many people were there. What this says is that Mike and his 3 friends were there. So there were 4 people total. It tells us that each person pays $13. We do not know the cost of the total bill. What I've done in this situation is I've taken the total bill, which I'm going to assign the variable X, and I've divided it by 4, or into 4 people are going to pay for it. So I've taken X, and I've divided by 4, and each person is paying $13. So I said X divided by 4 equals 13. Now to solve for X, I need to multiply by 4 on both sides. When I multiply by 4 on both sides, I find that X equals 52, or the original bill was $52. The next example says, Cindy and her friend found some money and split it equally. If both girls got $19, how much money did they find? We do not know the original amount of money that they found, but I know that they split the money equally, which means that whatever they did find was split into 2 equal parts, or whatever money they found was divided by 2. And I know that after it was divided by 2, each girl got $19. So I could say that X, the amount of money found, divided by 2 equals 19. When I solve for X, I need to multiply by 2 on both sides. When I multiply by 2 on both sides, I find that X equals 38, or the total amount of money that they found was $38.